Assalamualaikum and welcome back. The next common surface that I'm going to show you is hyperboloid of one sheet. Okay, this is a general equation for hyperboloid of one sheet, where here A, B, and C are constants. I'm going to go straight to showing you the example. So here I choose A as 1, B as 3, and Z is also 1. Okay, the technique is still the same. We're gonna look at a few views. One is from above, one from the front, and one from the side. And usually we'll pick 0 as the value. Okay, so let's look at the first view, which is the one from above. We're gonna let Z equals 0 and see whether the equation is valid. Okay, and here we have an equation of ellipse. Okay, so that is an ellipse. All right, so we sketch that on the xy plane. So here we have ellipse that is longer, parallel to the y-axis. So let's say this is 3, this is -3, and here we have on the x-axis at 1 and -1. So when we sketch this, we get an ellipse. Right. Okay, in the previous video I've shown you that Z can be positive and negative. Why don't we sketch for two more view from above? Let's say Z equals 1. When Z is 1, the equation would be x squared plus y squared over 9 minus 1 equals 1. And then rewriting this equation, we have an equation of an ellipse as well, but not in a general form. So we're gonna modify this so that we have 1 on the right hand side. So divide both sides with 1. So we end up with this 1 on the right hand side, and on the left hand side 9 times 2 is 18. And here we have x squared over 2, and again this is an equation of an ellipse, but it's going to be larger, okay, compared to when Z is 0. Okay, so it's going to be larger. So here we have the x-axis, y-axis, but now the ellipse intersect the y-axis at square root of 18 and negative square root of 18, and on the x-axis at square root of 2 and negative square root of 2. So when we plot this, we still have an ellipse, but it is larger compared to when Z is 0. Okay, and we can also pick Z equals -1, because here when you square negative value, you get positive. Okay, so this is the equation that we want to sketch. So when we replace that with -1, we end up with the same equation as this. Okay, the same when Z is 1. So we end up, the equation now would be an ellipse as well. So we have the same size ellipse on Z equals 1 and -1. Okay, so I'm just gonna say this is for Z1 and also for Z equals -1. So those are, we already have 3 views from above. One is for Z0, next is on Z equals 1, and then Z equals -1. Okay, so I think that's enough view from above. So we're gonna look at the view from the front and the side. Okay, now the view from the front is, we're gonna let x as a constant. So when x is a constant, our equation would be y squared over 9 minus z squared equals 1. So we have y squared over 9 minus z squared equals 1. And this is an equation of a hyperbola. Okay, it's an equation of a hyperbola where your hyperbola will open along the y-axis. Okay, because y is the one with a positive coefficient, 1 over 9 here. Here we have negative 1. So here we have y and z. So we have a hyperbola. It opens along the y-axis. So let's say that's a 3. And here we have a negative 3. So we have a hyperbola. Shaped like that, more or less. Okay, and then we need a view from the side. So the view from the side, we're gonna let y as a constant. Okay, I'm gonna pick y equals 0. So when y is 0, replace it in this equation, we end up with x squared minus z squared equals 1. And again, this is an equation of a hyperbola. Okay, so sketch this on the xz plane. Oops. Okay, so here we have xz plane. And since x is the one with the positive coefficient, your hyperbola open along the x-axis. So let's say this is 1, and here we have negative 1. So our hyperbola open along this. Right, so now we have all the views. We have one view from the side, one view from the front, and we have 3 views from above. One is for z0, and for z equals 1 and negative 1, we have the same size of ellipse. Okay, they're the same size. All right, so we're going to put everything together in the xyz space. So here we have, oops, oh, it should be in black. All right, so we have z-axis, x-axis, y-axis. Here we have negative y, and here we have negative x, and here we have negative z. Okay, remember for z, we plot 3 level curves. One is for z0, and the other one is for z1. Okay, let's say that is z equals 1. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, this is z equals negative 1. Okay. All right, so on z equals 0, we have an ellipse where is our ellipse? Okay, here. It intersects the x-axis at 1 and negative 1, and on the y-axis at 3 and negative 3. Okay, let's say this is 3. 1, 2, 3. And let's say that's a 1. Here we have an ellipse. And on the z equals 1 and negative 1, we have the same size ellipse. It intersects the y-axis at square root of 18 and negative square root of 18. That would be, what is that? 4 point something? Okay. So it's a bit larger compared to this, so 4 point something. So let's say here. 1, 2, here. And square root of 2 is 1 point something. So if that is a 1, so 1 point something is here. Same length. And we have the same size of ellipse on z equals negative 1. So it will intersect here. Same size. And here as well. Okay, and here. So we have the same size of ellipse on z equals 1 and negative 1. Okay, same size of ellipse when z is negative 1. Is that the same size? Okay, more or less. All right, and then we have this is the view from the front. We have a hyperbola. It intersects the y-axis at 3 and negative 3. So here we have 3 and negative 3. So we have hyperbola like so. Okay, and you can see the shape already. This is called okay, here, and this is the view from the side. Oops. This is the view from the side. We have a hyperbola as well. I'm going to use a dotted curve here. Okay, so this is another common surface, which is called hyperboloid of one sheet. Okay, so this is hyperboloid because it's a hyperboloid, a combination of hyperbolas. Okay, so that's is one more interesting common surface that you see often. Okay, that's it for this video. Thank you.